CBT Nugget Network Plus series, Network Monitoring and Optimization. Well, network monitoring and optimization and the things that go along with that, like tuning and logging and troubleshooting, basically involves the process of tracking the performance of your network subsystems, your hardware, your software, your applications and protocols and services. First of all, to establish a baseline, and we talked about baselines in a previous nugget, and then based on that baseline, you want to identify various issues and resolve not only problems, but also generate results. And that's what we're going to talk about here in this first bullet point. We'll start out here looking at why would you monitor and optimize your network infrastructure. And so we'll answer those questions. Then we'll look at the main techniques and methods, and we'll define these that CompTIA wants you to know for the Network Plus exam. Then I'll take you on a survey of some tools and utilities and logs, and we'll use some of the applications that you're familiar with already in this Nugget series. As a matter of fact, I'm going to go ahead and use my Cisco Adaptive Security appliance because it has so many features and applications in it. It'll be a good example. But we'll also look at Wireshark, a packet sniffer, and talk about some other tools as well. Again, this exam is vendor non-specific, so you won't need to have any specific knowledge about any particular products. But that being said, we do want to understand the category of utilities and tools that we use for monitoring and optimizing our network. First of all, let's go ahead and answer the question as to why. Why don't we just install our hardware, deploy our applications and our services, and just get it working as good as possible, and then set it and forget it and let the organization run pretty much on its own? Why do we monitor? Why do we optimize? Why do we care? Well, here's some of the reasons. And a lot of this is going to come down to business. All right? It is this critical factor. You want to get the most productivity that you can out of your hardware and software and resources for as little money as possible. You want to lower the total cost of ownership of networking devices and your network infrastructure. So you're going to monitor and optimize to maximize, squeeze the most functionality out of your hardware and your existing software and your underlying network infrastructure. If you have a certain amount of bandwidth, a fast Ethernet, or a gigabit or 10 gigabit, you want a fine-tuned machine so that when you decide to introduce a voice over IP solution or a wireless solution or some new application like Microsoft SharePoint to the organization, you have been running this ship in an optimized fashion, and it's not going to cost you tens of thousands of dollars in financial outlay and in human resources and in time to grow your company. So we want to lower the total cost of ownership. We also want to monitor and optimize our network so that we can enhance productivity. We want to of course, get the most out of our applications. We want to enhance the productivity of the user. If end users have to wait 10 to 13 seconds for their web pages to load, or for email to download from the server, or they're spending hours troubleshooting video conferencing and web conferencing, it's going to affect productivity. It's going to mean downtime. It's going to be morale crushing. It's not a good thing for your organization, whether you're a non-for-profit or a government entity or military or a capital structure. So maximize, lower TCO, enhance productivity. You also want to monitor and optimize so that you can generate the necessary logs and reports and summaries and details and documentation that you need to meet that goal of constant improvement. So it takes reporting and logging and some real-time results to be able to get the answers you need to meet all of these other requirements. We also want to optimize our resource utilization, and that of course gets down to getting the most out of your memory and your processing and your database and your hard disk space, your network infrastructure, all of the components that make up networking. You want to optimize those and fine-tune them, just like you would an automobile or an airplane. We also want to monitor and optimize because it's going to lead us to shooting trouble in our network and responding to incidents. When trouble tickets are generated, I'll just put TT, when trouble tickets are generated to the service desk or the help desk, hopefully they've been constantly monitoring and optimizing the system so they have their finger on the pulse of the network infrastructure, their finger on the pulse of the protocols and services and routing and switching and security services. They're intimate with that process so the troubleshooting aspect can be done quickly and efficiently. You're also going to monitor and optimize to make sure that all of the processes that you've put in place, for example, some of the processes that we talked about earlier with change and configuration management, if you're not monitoring and constantly improving and optimizing, those processes will fall by the wayside and end up being an albatross around the neck of network operators, network engineers, and the entire organization. And we also monitor and optimize and audit to increase the security of our network infrastructure. So hopefully all of these reasons here give you the indication of how important this aspect of network engineering and network operations is. So let's go ahead and take a look at some of the key areas that CompTIA wants us to see. Next, we're going to isolate some of the techniques and methods for optimization and monitoring leads to this optimization. And we're going to start out with quality of service, QoS. Now, if you think about the modern network, the ones that you come in contact with at your business or your organization, as different types of user applications are being introduced into the network, you're starting to see demand by businesses to be able to support different types of traffic. Voice over IP traffic, IP telephony, video conferencing, audio video streaming, multimedia, and your business critical applications, for example, like database applications, have to be protected from other types of traffic. We have to be able to prioritize our business critical applications and our delay sensitive applications like voice over IP with some type of mechanism. And what we use here are quality of service policies. What quality of service policy means is this. You're going to categorize and classify your traffic based on different business needs, based on the way that it uses the network, based on the geography, based on its criticality or importance in your network, and then you're going to apply different methods and techniques to managing that particular types of traffic. We're talking about traffic in packet-based networks like Internet Protocol and all the different converged services that are used on the modern IP network. Now there's really four big issues that are facing our converged enterprise networks today. Number one is bandwidth capacity. If you think about the large graphics files that we move and using multimedia and combining voice and video, this is basically bandwidth sucking activity to our data networks. So we have to look at bandwidth capacity. Also, we have to think about delay. Delay end to end, okay? So delay end to end could be the delay from my IP phone that I'm using in my headquarters to your IP phone that you have at the branch office. So we've got this end-to-end delay between the client end station and the server that's serving up some type of service. We've got serialization delay, which is a fixed delay. Serialization is the process of placing those zeros and ones, those bits, on the channel or the circuit. Propagation delay is the time it takes for frames to get across the physical media. We've got variable network delay, the time it takes for a router, for example, to look up a route in its routing table and then change the header and then switch it and put a new frame on it. That's a variable delay. We also have what's called jitter. Jitter is the difference in the total end-to-end delay values of two voice packets in a voice over IP flow. So jitter can affect the quality of our voice over IP. We also have The fourth big issue we have to deal with, and quality of service helps us address this, is packet loss. Okay? Congestion, especially in your wide area network, is going to cause packets to be dropped, and that's going to result in speech being dropped out on a voice transmission, or the stutter effect if you're trying to do a multimedia or a web audio video streaming session. So those are the big four that quality of service addresses for us. One of the first things we're going to do for quality of service is we're going to classify our traffic. And we'll also typically classify traffic into four or five categories. So this is something that has to be done by the network operator, network engineer. You're going to have your voice traffic. That's kind of in a class all by itself. You have mission critical. Okay, so I'm going to put your most mission critical traffic, for example, your key database application or your critical business application. You have what's called transactional traffic. This would be database access, transaction services like e-commerce, interactive traffic. Then you have what's called best effort. Best effort is, lower priority, get it there any way you can. Internet traffic, email traffic. And then you have a category which is called scavenger. And scavenger is typically stuff you may not want in your organization, or it's the least important traffic. And that would be things like peer-to-peer file sharing applications like Napster and Kazaa and Morpheus. Maybe even Instant Messenger falls into this category as well. So you'll have to classify your traffic so you can apply different policies to those different classes. Then the next thing we're going to do is, logically, we're going to set a minimum bandwidth guarantee for each one of those classes of traffic. We'll set a maximum bandwidth guarantee for those classes of traffic. We'll assign priorities to those classes of traffic, and then we'll use quality of service technologies. And those quality of service technologies are going to do processes like queuing, creating queues or buffers, or lining up different traffic differently, and then managing congestion. That's basically what we do with quality of service. Now, the mechanisms that we use, the specific mechanisms of quality of service, go well beyond the scope of this Network Plus series, but you need to understand generally what quality of service is. So a real-world application of quality of service would say we're going to classify our traffic. Let's say we're going to have our internet class of traffic. Then maybe we're going to have our remote office or branch office class of traffic. And of course, we're using IP phones here. Maybe you've got another extranet partner, and this extranet partner would be another class of traffic. And maybe the extranet partner is using audio video streaming technology to do conferencing or web-based training. And so you've got all of this traffic going in, but a lot of traffic going out, being downloaded from servers. So we will use quality of service mechanisms to manage congestion, to create different types of queues, and to prioritize traffic as high priority traffic or low priority traffic. So these mechanisms are congestion management, congestion avoidance, and the next bullet point, which we would call traffic shaping. Let's talk about traffic shaping for a second. Traffic shaping is using a policing mechanism to control the maximum rate of traffic sent or received on an interface. So for example, this router interface here at our remote office branch office, or this outside interface on this firewall. Now, traffic policing is often configured on the interfaces at the edge of our network, on this firewall, or maybe a high-end router here that connects to our provider. And we use it to limit traffic or shape the traffic into the network and out of the network. We can control the traffic going out an interface to match its flow to the speed of the remote target interface. So for example, this router interface right here and network pipe may be a lot bigger than the one that's over here at the remote office branch office. So we can police it accordingly. Now, traffic policing and traffic shaping can differ, okay? And the difference is the way they respond to traffic that actually violates the policy. Policing typically is going to drop the traffic if it violates the policy. For example, you set a maximum data rate. So think about policing as, a cop. But traffic shaping quality of service mechanisms are typically used not to drop the traffic, but to limit the available bandwidth. So like squeezing the pipe. And traffic shaping can be used along with quality of service mechanisms. These are just a couple of powerful techniques and method for network optimization. And of course, monitoring is going to play into this, because if you implement quality of service and traffic shaping, you're going to be constantly, on an hourly basis, monitoring your network. Now let's go ahead and keep our same sample network here and talk about high availability. Now I've already talked about things like network load balancing previous in this Nugget series. And if you go back and you think about the network load balancing concept, where you're basically sharing the load among two or more servers in a cluster of servers, that gives you high availability. In other words, you want to optimize and monitor your network so that your network servers and your services are available, if you can, 99.99% of the time. And so what we can do with high availability as a solution, as a technique or a method, is to provide redundancy. So for example here, I've taken that same diagram and I've got a redundant router here. So this router can provide the same services as this firewall, and I can have some redundancy and some failover links between these. So if one of these goes down, it can fail over to this other firewall or router. And we can use protocols like hot standby router protocol to manage that for us. We might also have redundancy from our headquarters with our provider. We might have service provider A and service provider B. We might have a service provider that we use for just basic internet web access, and maybe a different service provider for wide area networking. And that way we have some redundancy or high availability to get out of our network and to get into our network. And that's really important if the organization is doing e-business or e-commerce. In other words, their main products and services are being sold online. You can see also here, I've got redundancy with my perimeter devices, whether it's a router or an adaptive security appliance or a firewall. I want to have redundancy there and some failover mechanisms for high availability there. The same thing with my servers. So high availability is a method, it's a technique to optimize your network, and this can be done for optimization and performance gains, but it can also be part of a security policy in the sense of it's a disaster recovery solution too. Disaster recovery in the sense if one of your servers or devices goes down, you can fail over to another device. And sometimes this redundant device may actually be on a high-speed fiber network over in a whole separate building. So you can combine high availability and failover with disaster recovery. Now, another reason why we monitor our network devices, our routers and switches and firewalls and IDS, IPS and network operating system servers is because of issues revolving around sizing or accommodating for the growth of your network. And so monitoring is an important aspect in determining how we're going to grow our network, how we're going to accommodate for mergers and acquisitions and expanding our business. So if you expand your business or you merge or you acquire, you need to increase your network infrastructure. And so sizing is going to involve two general concepts. It's going to involve sizing up and sizing out. Okay? Sizing out means I'm going to add the number of servers or add the number of devices, increase my network operating servers, increase my number of blade servers. Sizing up means I'm going to go to a new hardware solution, a more expensive, bigger, beefier hardware solution with more memory, with faster processing, with more port density, with a newer operating system, with more features. And so that's a decision you have to make, and only monitoring and optimization strategies can lead you to the best choice. What we're seeing done more often than not is sizing up instead of out. Sizing up can be done much cheaper because most of our devices now are modular. So we can just add modular components to the chassis. Also, we can use virtualization. We can virtualize servers. We can virtualize firewalls. We can virtualize IDS and IPS into virtual machines, and that way we get to size up or scale up. It's also referred to scaling up and scaling out. We can scale up by just virtualizing it within the actual memory and processor. That's another technique and method for optimization, and of course only good monitoring will give us the right results. Next, we have caching engines, which are really an interesting way to improve network performance and utilization and optimization. A cache is basically just an area of memory which is used to pre-store information. For example, devices are going to learn about others' MAC addresses to the devices that they're directly connected to. And so they can cache or store that information in a memory buffer, a memory area. So you're basically storing information that you're going to use on a regular basis so that you don't go through a lengthier, more process-intensive process to actually get that information. Routers cache things all the time. They'll cache the network topology, or they'll cache destination IP address to MAC address mappings, things like that. So caching engines can be added to networking devices. For example, the Cisco router has a caching engine called Cisco Express Forwarding, and it basically takes an entire copy of that MAC address table and the mapping to IP addresses and stores that in memory so it can switch stuff very quickly without having to go down and even use the processor or lower level elements of the operating system. And you see caching also, for example, with things like domain name service. You'll have a domain name service caching server, and you'll put this caching server over here at a remote office across some slow WAN link to the headquarters. And what you're doing is you're just basically replicating all or part of the database to this caching server, so that when clients that are over here on this remote office link don't have to go over the internet to the headquarters DNS server to resolve some type of IP address to domain name mapping. So caching engines and caching processes are very popular on network operating systems, on routers and switches, and even firewall devices to improve and speed up the process. And of course, monitoring will come into play because we can use logs and we can use reporting techniques to monitor the results of those caching engines. Matter of fact, we can use logs and reports and summaries and all types of output mechanisms for all of these things we're talking about here. Quality of service, traffic shaping, high availability, sizing, caching engines. Now let me clean my screen up here as we talk about this last technique and method for optimization. Next, I want to talk about front-end, back-end servers. And what the concept of front-end, back-end servers does is this. It takes a front-end server, which is going to have the access to the end user or the end station, and then it offloads a lot of the applications and services and responsibilities from the back-end server. Typically, historically, a server would do everything. It would have data storage, it would have application services, it would handle all the networking processes, security, caching, all of the policy that you would apply on an end user by end user or group of users basis. But now what we can do is, on the back-end server, we can have mostly just the database and other storage mechanisms and policies that manage just the database and other specialized services. And then on the front end, of course, what you want to have back here is very fast storage, lots of storage, a fair amount of memory. But on the front end server, you want to have super fast multiple processing, you want to have lots of RAM memory, and you're going to have this front end server deal with a lot of the client requests It can deal with our policy. It can apply policy. It can apply caching services. It can do proxy services. It can actually take the raw data from the back-end server and use something like XML and present that to the user in their web browser. I could also have the security encryption and decryption done here on this front-end server and let the back-end server do what it does best, just deal with data and presenting the data that we need. Mining the data and presenting just exactly what we need to the front-end server. The front-end server could also be not just between a multi-layer switch here, but there could be a firewall in between these two devices so that the front-end server only has to talk to the back-end server using one particular protocol. So I only have to open up one hole in this firewall for these two devices to talk. The front-end server, for example, with email, it can do all the POP3 and the IMAP4 and the SMTP and all that type of stuff, and then it can just open up a single channel to this back-end server. That's much easier to secure. So we're separating the duties here. One last example, this front-end server could be a client access server that's dealing up our Outlook web access pages to the remote user or the remote site, and then the data in the back here, the database servers, can be just basically generating the raw data to this particular front-end server so it can present what the client sees in Outlook web access. So back here you've got your databases, you've got your maybe public folders, SharePoint, web farms, the mailboxes, okay? Mailboxes for users, and the front-end servers do all these things that we talked about before. Front-end, back-end servers. Another great way to optimize and enhance your network infrastructure, and of course you can imagine this is something that also is going to be monitored very closely. Let's go ahead and take a look at some tools and utilities that we can use for monitoring and optimization. This is a tool, actually, I just taught and this is a coincidence, but I just taught a Cisco security class today online to some people, well, all over the world. And one of my students turned me on to, this is actually his site, opennetadmin.com, and you can go up there and you can run a demo. This is a pretty cool site that allows you to go online and kind of create your network inventory and to map out your network. You can look at your different subnets and your host and DNS domains, and you got some tools here you can use. You can add hosts and subnets and VLANs and blocks of addresses. You have some admin tools here that you have available to you. A lot of management tools to manage your network. A little simple IP calculator over here. And, you know, there's just a lot of tools that are up there on the internet that you can use to do inventory, to map out your network, to create a view of your infrastructure without going on and spending a lot of money. And of course, on the Network Plus exam, you aren't really expected to know and deal with a lot of proprietary tools. But realize there's just a whole heck of a lot of tools up there. Be careful, though, of course, downloading freeware and shareware to your system, because, again, those could be Trojan horse programs that are actually going to cause more problems, more harm than good. But this is a nice little site, OpenNetAdmin, little demo here. Check out their tool. Now I'm using a Vista machine, and you can see here I'm in Control Panel and Administrative Tools, and I've got some tools that are available to me, you know, right here from the client side. I've obviously got my computer management, but from a networking standpoint, I'm probably more concerned with tools like the Reliability and Performance Monitor, which I have available to me, and this is obviously the perfmon tool, which allows me to go ahead and do quite a bit of monitoring, looking at my performance, looking at reliability, creating reports, looking at software updates, generating reports, system reports, user-defined ports, so performance. I can see, obviously, CPU disk network is what I'm probably concerned with here for this end user station. And I could always connect to an end user station using RDP or remote desktop protocol or terminal services, and I could monitor and manage a station remotely that way as well. If I'm done with this tool, I can always go and take a look at my event viewer, and this is my log on my Windows Vista machine, and I have the same type of thing in a Windows 2000, 2003 server, 2008 server. It's going in and reading my logs, and by default I'm going to have a system log, I'll have a security log. You can see admin events here, and I can see the critical events, error events. You can move down, scroll through those. Warning, there'll be a lot of those. Okay. Informational events. And if you click on one of these, it'll give you a summary of the information, which you can take a look at. Obviously over here I've got admin events. I've got Windows logs. These are the logs I have by default. Application log, security log, system log. I can choose an object and look at details on that information. This is going to show up in XML format, which makes it really easy to present into a web-based format. This tool is obviously very elaborate, but realize that on your network operating systems and your network clients, let's say for your Windows clients and your Windows server, one of the key utilities and tools that you're going to use for monitoring and optimization is going to be the event viewer and the performance monitor tool that I just showed you. Okay, I'm over on my network management station, and another tool or utility that you're going to have to become intimate with as a network professional for monitoring and auditing and optimization is a packet sniffer. And you can go up to ethereal.org or wireshark.org, and you can get this Wireshark tool and download it for free. And what I'm looking at right now is a capture of an open shortest path first communication. And what you're going to want to do is this. You're going to want to go up to their website where they have a whole database of sample captures of all different types of protocols and applications and services. And you want to start to dive into those and get a feel for the behavior of these network protocols, applications, and services. For example, I can move all the way up the OSI stack here, going from the data link layer to network layer 3. Showing the internet protocol, you can see this is IP version 4, protocol number 59. That's the OSPF protocol number. I can go and break down the OSPF information here, crack that open, look at the OSPF header. We're using OSPF version 2. Version 3 would be used for IP version 6. You can see this is a hello packet, and it's sent to multicast address 224.0.0.5. As I click on the different packet here, it'll obviously change this information that I'm seeing down here. That's the OSPF header, and this is the actual OSPF hello packet. And this is the packets that's exchanged between the designated router, as we can see right here, it's at 192.168.170.8, to multicast addresses to all the other routers in this particular OSPF environment. And you can see aspects of the OSPF protocol like the router priority, the dead interval, the hello interval, good stuff like that. You can actually break down into the actual packet itself down here. And so you're going to want to go up to wireshark.org and download some of these sample captures. For example, I might want to see a Microsoft. You can open this up and see this is Microsoft's Messenger service. We can come down here, we can see the Messenger service information, and you can actually see user information in here. Here actually showing a IP address, actually showing somebody's email address down here. As I go through here and open this up, these little packets, I can see different communication down here and showing up in clear text. So this is not a secure protocol. You could secure it with IP security, but again, you can break this down from the application layer down to the network layer. Here's the application layer, MSN Messenger service. You can go down to layer 4, TCP, and you can see the parameters that are being used here by MSN Messenger, all the way down to the IP layer, Internet Protocol, source, and destination IP address. So with a packet sniffer, you can monitor and generate a lot of information about your network. You can also use it to troubleshoot. You can use it for optimization. You can use packet sniffers for troubleshooting and for security. And again, you'll want to go get some sample captures or run this on Probably not your production network at your office. That may cause some problems, but if you can create a lab environment, or you can of course go up and get some of these and see the slammer worm. You can see some telnet information. Here's some raw WPA wireless security information. You can load up these captures and go get a feel for, here for example, the 802.11 beacon frame. And you can even see right here in the beacon, it's showing me my SSID Cisco-LI_82. So Packet Sniffer is a very powerful tool. Let's go back to our old friend the ASDM, the Adaptive Security Appliance Security Device Manager, which I think is a great tool to display and show monitoring and optimization and reporting and logging, all of the things that we need. The ASDM allows me to view up to 5 security appliances. I can see here I've got a device dashboard that shows the status of my interfaces and traffic status. I can also see the system resources, any VPN tunnels that are created. I've got a firewall dashboard here showing the TCP and UDP connection statistics, any network address translations that are in memory right now, any packets that are being dropped, looking and monitoring for possible scanners or TCP SYN attacks. I can also go look at the top 10 services, top 10 source IP addresses, and top 10 IP destinations. I can also see the access rules that have been hit in the last hour, the last 8 hours, or the last 24 hours. This is a very powerful monitoring and troubleshooting and optimization tool. Of course, I can go to the monitoring area, and I can see under monitoring I've got logging. And I can turn on logging, and this is syslog. This is the syslog protocol. You need to be aware of syslog. I've got these different levels: emergencies, alerts, critical, errors, warnings, notification, informational, and debugging. If I want to see my log buffer, I can click on view here, and I can see my syslog buffer. It's got the severity level. It's also got a date and time stamp. I've got a syslog ID. I've got the source IP address and destination IP address, as well as the source port and destination ports. You can see here a whole heck of a lot of SSL TLS going on between this particular workstation and my HTTPS session to my adaptive security appliance. You can see I've got a nice long description here in this area of all the things that are happening. So and as I do this, I can also look down here for an explanation. As I click on these, I can see a recommended action, none required, but a very powerful tool indeed. This is my log buffer, which is being stored here on this management station. But I can also do some real-time log viewing, and a network operator or a security auditor would sit at a station and they would monitor systems like this. I need to create some real-time activity, so let's go ahead and go to Tools, and I'll do a ping real quick. 192.168.2.10, and no, let's go ahead and do 2.2. Ping that and try 1. That didn't work. Try 1. That's successful. Okay, close that down. And now I can view, here it is. This is my real-time log viewer. So I can be sitting as my station. Obviously, this was an active device. This real-time log viewer would be showing up, obviously, a lot of information. So if 5 and 6 is not high enough, I could say, well, just show me, emergencies or alerts. I can filter this out, for example, and I've got a lot of capabilities here. I can save this log file, I can clear the log file, change the color settings, and so syslog is a very powerful tool. Now, if you were in a large enterprise organization, it's quite likely that you would use a dedicated syslog server, and a lot of devices would send information to that syslog server. And you could group up those devices by their particular facility, and that syslog server could be used by a network operator to do real-time monitoring, logging, reporting, optimization, troubleshooting, and of course security auditing as well. And by the way, you can go up on the internet and get a free syslog server. Kiwi, Kiwi, is a free syslog server. So just a nice little tour here. Of course, we could just spend days and days and days looking at all the options out there, but you want to understand that part of your role as a network technician, a network operator, a network engineer is going to be daily, hourly optimization, monitoring, and using a wide variety of tools to get the pulse of your network. All right. Well, in this CBT Nugget of the Network Plus series, we looked at three main knowledge areas as it relates to network monitoring and optimization. First of all, we answered the question, why monitor? Why optimize? Then, we looked at several techniques and methods that can be used to optimize your network. Then, we took a brief survey of some tools and utilities and logging capabilities that you'll need to become familiar with to be a network operator and ultimately a network engineer. Well, I hope this CBT Nugget has been informative for you. I want to thank you for viewing. See you later.